Alrighty, boys and girls, welcome to the last section in Chapter 6, Section 8, Solve Two-Step Inequalities. Now, we're going to solve two-step inequalities just like we would solve two-step equations with the same one exception that we went over in the last section. Now, in case you forgot, that exception is if you multiply or divide by a negative number, reverse the inequality symbol. Now, if you add or subtract, doesn't make a difference. If you multiply or divide by a positive number, doesn't make a difference. But if you multiply or divide both sides by a negative number, you have to reverse that inequality symbol. Okay, so let's take a look at some of these examples. Okay, on the left I have the equation 3x plus 4 equals 16. On the right I have the inequality 3x plus 4 is greater than or equal to 16. Very similar. So I want you to see the similarities and how I solve both of these. So, starting with the equation on the left. First, I look at the left-hand side, the side that has the variable, and I identify the constant. The constant is plus 4, and to take care of that, the opposite of plus 4 is minus 4. The plus 4 and minus 4 cancel each other out on the left, leaving 3x, and on the right, 16 minus 4 is 12. Now I'm left with a one-step equation. 3 multiplied by x equals 12. The opposite of multiplication is division, so I'm going to divide both sides by 3. The times 3 and divided by 3 on the left cancel, leaving x. And on the right, 12 divided by 3 is 4. Now in my inequality on the right-hand side of the paper, again, I look at the side with the variable first, that's the left. I take care of the constant, plus 4, by subtracting 4 on both sides of the inequality. On the left-hand side, the 4's cancel, leaving 3x. And on the right-hand side, 16 minus 4 is 12. Now, since I did not multiply or divide by a negative number there, all I did was subtract 4, that inequality symbol stays the same. Now, just like in the previous problem, to get rid of that times 3 on the left-hand expression, 3x, I'm going to do the opposite of multiplication, division. The 3's on the left cancel, and on the right, 12 divided by 3 is 4. Now, since I did not divide by a negative, I divided by a positive number, that inequality symbol stays the same. So I have x is greater than or equal to 4. Now to graph both of these, what we do is draw our simple number line and our circles. Now, on the left, x equals 4, so I fill that circle in. Now, since x cannot be less than 4 or greater than 4 here, I do not shade in either side. I just leave it like that. This is the graph of x equals 4. Now, on the right, I draw my simple number line again, and my circle. Now here, the symbol says x is greater than or equal to 4. Since x can equal 4, and I know this because of this line, I'm going to shade that circle in. Also, x can be greater than 4, greater than or equal to. The numbers greater are on the right-hand side, so I shade that in. Okay, let's take a look at another example. Okay, on the left-hand side, 7 minus 2x is greater than 11. First thing I want to do is get rid of that constant, the positive 7. I do that by subtracting 7 on both sides. On the left, I'm left with minus 2x. And on the right, 11 minus 7 is 4. Because I did not multiply or divide by a negative, the symbol stays the same. And now, to get rid of that negative 2, since it's being multiplied by x, I do the opposite, which is division. On the left, the negative 2's cancel. And on the right, 4 divided by negative 2 is negative 2. Because I divided by a negative number, the inequality symbol switches. In the next equation, first thing I want to do is take out that 14. Since there's no symbol in front of it, I know it's positive, and the opposite of positive 14 is minus 14. On the left, they cancel, leaving negative 4x. On the right, 2 minus 14 is negative 12. Because I did not divide or multiply by a negative number, the inequality symbol stays the same. Now I have negative 4 multiplied by x. The opposite of multiplication is division. On the left, the negative 4's cancel. And on the right, negative 12 divided by negative 4 is going to be positive, because two negatives make a positive, 3. Because I divided by a negative number, the symbol switches. And we have x less than or equal to 3. Let's take a look at one more example. Okay, so first thing I want to do is take out the constant. Opposite of plus 5 is minus 5. Again, I did not multiply or divide by a negative, so the inequality symbol stays the same. Now I have x divided by negative 2. The opposite is multiplying by negative 2. On the left, the negative 2's cancel. And on the right, negative 4 times negative 2 is positive 8. Because I multiply by a negative number, I flip the inequality symbol. And that's it for solve two-step inequalities.